General properties. General properties of first row. First row of transition. First row means your form Z starts from 21 to 30. Okay. So oxides. Formation of oxides by these elements. So the first row generally forms oxide. They generally form oxide of oxides. Forms oxides of formula MO, M2, O3, M3, O6, MO2, and MO3. So they generally forms first of generally form these types of oxides. Okay. These oxides are generally formed.
Yes, sir.
Are generally formed when transition element are heated. High temperature. Okay.
Yes, sir.
These oxides are basically acidic, basic, and amphoteric in nature. They may be acidic also, acidic oxide, they may be basic oxide, and amphoteric means they either behave as acidic, sometimes they behave as acidic in nature, and some they behave as basic in nature. Okay. So acidic oxides, basic oxide, and amphoteric oxide. Okay. Correct. For example,
Yes, sir.
Very important point. First, the oxides behave as basic nature. Oxides are basic when they have when metals are in lower oxidation state. When metals are in lower oxidation state. OS. I am writing OS as oxidation state. So if metals are lower oxidation state, they are basic oxides. If they are higher oxidation state, if they are if they are in higher oxidation state, then they behave as acidic oxide. Then they behave as acidic oxides. And if they have intermediate oxidation state, then they behave as amphoteric oxide. Okay. Clear? Because we have to study the general properties of only first row of transition element, because in your syllabus only the general properties of first row of transition element are given, that is from 21 to 30. So we will talk about that only. Okay, Niklesh? We do not go deep about that. You can check once again, check it. It is we have to study the general properties of first row of transition element. Check it once again, because I am not going deep then. When is your board examination?
So like they haven't given the date yet, but like it's like they said that it'll start on April 26th.
Yes. They will start in April 26th. Okay, then we have revision. We have ample of time. Okay.
Yes, sir.
But for pre-board exam, we have to finish it faster. Yeah. Your pre-board exam will be from March.
Yes, sir. No. 1 second. So I'll tell you the exact date. So it'll be on the 21st
of Feb.
So no, sir. This month, sir.
March.
No, sir. February. So this month.
Okay. So it is coming. Okay. See whether it is given as yes. 31st row of transition element is given. Yes.
Yes, sir.
So it is given first row of transition element. First row, that is 20 to 30.
Yes, I think yes, it's first row. Yes, sir.
Okay. So talking about the oxidation state of oxides. Oxides are basically acidic, basic, or amphoteric in nature. If the elements show lower oxidation state, then it will be basic in nature. Higher oxidation state, then it will be acidic in nature, and intermediate oxidation state, then they are amphoteric in nature. Okay, got it?
Yes, sir.
Now, for example, if you take one example, for example, oxides of magnesium. For example, oxides of magnesium. Manganese. Manganese. For example, MNO, manganese oxide, then Mn2O3, Mn3O4, so if you find the oxidation state of these, so it is, if you check, it is Mn2 having +2 and +3 oxidation state, so they are basic oxides. Then it is +8/3 and it is +4. This is amphoteric oxide. And this is a +7. So it's acidic oxide. Okay. When we move from left to right, this side, the basic character decreases. Basic character decreases. And acidic character increases. Got it? Okay.
Yes, sir.
The basic, and when we talk about the basic oxide, for about basic oxides, basic and amphoteric oxides. Amphoteric oxide. Basic and amphoteric oxides generally get dissolved in HCl to form hexaquinoion, that is M MH2O hexaquinoion. Okay. Basic and amphoteric oxide generally get dissolved in HCl to form hexaquinoion. Okay.
Okay, yes, sir.
The formula for hexaquinoion is M. M is a metal, 8 molecules of water, and N plus, the oxidation state. Done?
1 minute, sir. Yes, sir.
Yeah. Okay. Some oxide dissolve with acid or base. Some of the oxides dissolve in acid or base to form oxometallic salts. Oxometallic salts such as potassium chromate, potassium chromate, potassium chromate, potassium dichromate, and potassium permanganate. Done.
Yes, sir.
Nicholas, can you check please that we have to talk detail about this compound potassium dichromate is the syllabus. What does the syllabus saying that? 1 minute, I will check this. If you have to talk detail about this or not. 1 minute. We have to see the. Okay, so we are talking about D block configuration, electronic configuration, like Republic first law of transition, that is metallic character, ionization, enthalpy, oxidation, ionized radiate, color, collective point, magnitude, and alloy formation. Okay. Then we do not have to talk this detail about this compound. Okay. Okay. The detail of these compounds are not given in the syllabus. Please check in the syllabus that you have sent to me. It does not tell about the detail of these compounds. It just is in general introduction, electronic occurrence and characteristic of transition, the general transition property of the first row of transition metallic character,
Yes, sir.
ionization. Yes, then here they are not talking about the any. Okay. So okay. Then it all length electron. Then fast. Okay. General trend, general configuration and characteristic first row. Then general first row of transition. Okay. So this is the important of these properties. We have already discussed these properties. Okay. Okay, Nicholas. Then we will start with lanthanide series. Okay.
Yes.
Yeah. Because then we talk. lanthanide series and actinide series. So we will talk about lanthanide series. Lanthanides. The F block elements generally has two series of F block elements. And these F block elements are known as inner transition elements. These F block elements are inner transition elements. Inner transition elements, or they are also known as rare earth metal element. Rare earth element. Got it?
Yes, sir.
These two F block group series are known as lanthanide and actinide. Lanthanides and actinides. The lanthanide includes the filling of 4f orbital. While actinide has 5f orbital. So lanthanide includes the filling of 4f orbital, whereas actinide includes the filling of 5f orbital. Okay. Okay. Written.
Yes, sir.
The lanthanide series. If we talk about the lanthanide series, 1 minute. 1 minute. I am going to share. Yes, Nikhil. Can you see the periodic table?
Yes, sir. Yes, sir.
So these are lengthenide series. Okay. So they start from the lengthenide series, basically starting from this 57. Atomic number 57, 58, 59, 60, 61, 62, 63, up to 71. Okay. So you can write it, the lengthenide series basically starts from atomic number. The lengthenide series starts from Z57 to Z70L. Okay. And how many elements are there? In 14 elements are there. Got it? So first member of this group is lanthanum. The first number 57 is lanthanum. Okay. First number is lanthanum, and the last number, that is 71, is lutetium. 71 is lutetium. Okay. Okay, Nicholas.
Yes, sir.
And they are basically placed in which period? Sixth period. They are basically placed in first period, second period, third period, fourth period, fifth period, sixth period. So basically they they are presented. They start from 56th period, sixth period. Okay. After barium. 56 is barium. After that, the lanthanum series starts. Okay. Got it?
Yes, sir.
Written, then I can switch on.
Yes, sir.
Okay. So they have the lanthanide series has partially filled f orbital. They have partially filled f orbital. Lanthanide they partially filled 4 of orbitals. Okay. Got it?
Yes, sir.
Now we talk about the general physical and chemical properties of lanthanide series. General physical and chemical properties of lanthanide. First, lanthanides are generally silvery white metals. They are generally silvery high white metals having low tensile strength. Having low, the tensile strength is very low tensile strength. Tensile strength. They are good conductors of heat and electricity, and they are good conductors of heat. Good conductor of heat and heat and electricity. Second, density. If you talk about density, they have high densities. Lanthanides have high density. The density range from between 6.77 gram per centimeter cube to 9.74 gram per centimeter cube. Okay. The density generally, very important point. The density generally increases. The density generally increases. Generally increases. Density generally increases with increase in atomic number. With increase in atomic number. As the atomic number increases, its density going to increase. Second is, third is melting point and boiling point. Already we have discussed it. Melting point and boiling point. They have high melting point. They have basically high melting point. They have high melting point and boiling point. They have high melting point and boiling point. They have high melting point and boiling point. Basically, they have no general trends. They follow. They follow no general trend. They follow no general trend in boiling point and boiling point. We cannot say that like melting point increases from lanthanum to lutetium or they decreases from lutetium. There is no general trend, okay? But they have generally have high melting point and boiling point, okay? Got it?
Yes.
Then ionization energy. The ionization energy. They have low ionization energy. Low ionization energy means the outermost electrons are easily removed, okay? Okay?
Yes, sir.
The IE1, that is ionization energy of first electron, and the ionization energy of second electron, that is IE2. Values are quite comparable, to that of alkali metal. Quite comparable to that of melting and boiling point and boiling point. Sorry, to that of alkali earth metal. So they are very much similar to that of alkali earth metal. Okay. Got it? So they are outermost. This means that like alkali metals, so they are the alkali earth metals are very electropositive elements. We know that. They can easily give their outermost electron to form electropositive element. Okay. Okay. So they are basically behave as metal. So from this term we can say that they behave as metal. Okay. Got it?
Yes, sir.
So this means that if you talk about the electropositive character, next is your electropositive character. Electropositive character. If we talk about electropositive character, so lanthanides have generally high electropositive character due to low ionization. They have, they have high electropositive character. They have high electropositive character due to low ionization energy. Due to low ionization energy. Got it?
Yes, sir.
So they behave an electropositive element due to low ionization energy. Then colored is ions. Many of the lanthanide ions are colored. Many of them are colored. Many of the lanthanides ions are colored in nature. Colored in nature. In solid state. In solid state as well as in solution. The color is attributed to F transition. This color is due to, yeah, I am writing here. This color is due to, this color is due to transition of electrons, due to transition of FF electrons among themselves, among F orbitals. Because F orbital regenerate orbitals, we have same amount of energy, and F has partially filled electrons. So these electrons can jump on one orbital to another orbital, giving lot of energy. So that is why the energy is fall in the visible region of the electromagnetic radiation. So these are visible in color. So they form color compounds. Okay, got it? Niklesh, got it?
Yes, sir.
So what I have said that why there is color ions in the lanthanide series as the F block element. F block element are partially filled electrons. These are F block 1, 2, 3, 4, 5, 6, 7. So they have partially filled electrons, and the partially filled electron, and generally the some and vacant also. So generally what happens, they are degenerate orbitals. It means they have equal energy, degenerate orbitals. Because they have equal energies. So these are electrons can shift in one over the other, and while shifting they liberate lot of energies, and these energies fall in the visible region of electromagnetic radiation. So they are basically colored in nature. Got it?
Yes, sir.
And next is magnetic behavior. Magnetic behavior. Magnetic behavior. The lanthanide ions generally show paramagnetic due to the unpaired electrons in f orbital. These lanthanide ions, these lanthanide ions generally show the due to unpaired electrons in f orbital. Lanthanide ions generally show paramagnetic due to unpaired electrons in f orbital. The lanthanide ions generally show paramagnetic behavior due to unpaired electrons in the f orbital. Okay. Got it?
Yes, sir.
Next is atomic and ionic radii. Atomic radii. Ionic radii. Or we can say lanthanide contraction. Lanthanide contraction. The lanthanide having tripositive lanthanide ion, lanthanide ion, that is so steady and gradual decrease in moving from lanthanide to lutetium. So there is decrease in the atomic radii as we move from left to right in the periodic table of the lanthanum series due to increase in the in effective nuclear charge. Okay, got it?
Yes, sir.
Written? Written?
Yes, sir.
The steady decrease. The steady decrease in atomic radii with increase in the atomic number. Increase in atomic number in tri-positive lanthanide ion is called lanthanide contraction. Lanthanide contraction. Done?
Yes, sir.
Cause of lanthanide contraction. The cause of lanthanide contraction is increase in the effective nuclear charge of effective nuclear charge due to increase in the effective nuclear charge of adding electrons to the F of F. So effective nuclear charge increases due to which electrons attraction increases, and that's why atomic radius decreases. One. नहीं उसके बाद कर लेना ठीक है डन निखिलेश निखिलेश डन
Yes, sir.
okay consequence of bentonite contraction next is consequence of consequence of lengthenite contraction. What is the consequence of lengthenite contraction? First, similarity. Due to lengthenite contains similarity between similarity of third, second, and third transition series. Okay. There is similarity of second and third transition series. Okay. Due to lengthenite contraction, the atomic radii becomes very small. Due to there is very much similarity between the second and third transition series. Okay. Got it?
Yes, sir.
Then second is your separation of lengthenite. Separation of lanthanides. It is very difficult to separate lanthanide because of it is very difficult to separate lanthanides because of having similar properties due to the lanthanides have very similar properties. So very difficult to separate these lanthanides on the basis of physical and chemical properties due to lanthanide contraction. Okay. Got it? So it is very difficult to separate lanthanide because of having similar properties due to lanthanide contraction. Okay. Next is variation in basic strength of hydroxide. Variation basic strength of hydroxide. So what happens? The basic strength of hydroxide, the basic strength of hydroxide basically decreases basically decreases from lithium hydroxide to that of lithium hydroxide. And this is due to lanthanide contraction. Due to lanthanide contraction. Due to why? So due to lanthanide contraction, the size of the size of the size of lanthanide decreases. Lanthanide decreases, due to which due to which due to which basic character decreases. Got it? Done, Nicholas?
Yes, sir.
Next is oxidation state. Oxidation state. Oxidation state. The lanthanide, very important. The lanthanides have a principal oxidation state. The lanthanides have principal oxidation state of M+3 ion. Got it?
Yes, sir.
So if we talk about the lanthanide series, the lanthanum, gadolinium, and deuterium plus three, they three have a plus 3 oxidation state, and they have stable oxidation state. Because why they have this plus? Because they have empty, half filled, and fully filled F orbit. And fully filled F orbit. Done.
Yes, sir.
Next is chemical reactivity. Very important. Many metals, many lanthanides reacts with carbon to form salt like carbides. Salt like carbides, and they can also react with hydrogen to form hydrides. So they can react with carbon to form carbides and hydrogen to form salt like hydrides. Okay.
Yes.
Lanthanide can also react with lanthanide can also react with sulfur, so oxygen and sulfur to form oxide like M2O3 and sulfides respectively. For example, selenium S2O3 or cerium sulfide S2. free to selenium oxide and selenium sulfide. Done. Next is done.
1 minute, sir. Yes, sir.
Next. Next is oxides and hydroxide. Oxides and hydroxides also react with CO2 to form carbonates. That is M2CO3 twice. M2CO3 twice. Done.
Yes, sir.
Next is uses of lanthanides. Last topic, uses of lanthanides. So first is alloy of lanthanide with 3% magnesium. Magnesium and 3% miscellaneous chemical is used in jet engine parts. Second, ferric sulfate, that is CeSO4 twice, is used in oxidizing agent, is used as oxidizing agent in volumetric analysis. Sea salts are used in cerium salts are used in dyeing cottons, in lead accumulation, in lead accumulation, and as catalyst. Fourth, lanthanum oxide is used in Cook's lens, which is used for absorbing, which is used against production of UV radiation. Done. Eclipse done. Eclipse.
Yes, sir. Done.
Fifth, many lanthanide oxide are used in many lanthanide oxide are used in TV tubes as phosphorus. Next, cerium oxide is used to polish glass. Then most important, Mish milk metal is an alloy which contains a rare earth metal, that is a transition rare earth metal, that is lanthanide, 94.95%, iron 5%, and sulfur, carbon, silicon, calcium, calcium, and aluminium. Okay. I am continuing from here. The main rare earth metal, that is So the main rare earth metal. The main rare earth metal. Earth metal is the main rare earth metal is cerium, 40%, then lanthanum and neodymium as 44%. What are the uses? These metals, they are used as pyrophoric, the alloy that catches fire, as pyrophoric in cigarettes, gas lighters, flame throwing tanks, tracer bullets, and shells. So this metal is very important, which is made is a alloy which is made of rare earth metal. The rare earth metal contains 94.95%, and other trace elements are sulfur, iron that is 5%, sulfur, carbon, silicon, calcium, aluminum. The main rare earth metal is cerium that is contains 40% out of 95%, and next 44% is lanthanum and neodymium. These are used in pyrophoric in cigarettes, gas lighters in flowing tanks, and trace bloods and cells. Okay, got it?
Yes, sir.
So here we have finished the lanthanide series. So I think we have completed our syllabus, or something is left. One minute, I check it. You have done it?
Yes, I think we finished it. Yeah.
So we have finished it. Now we have to do the revision of your physical chemistry, that is from electrochemistry. Okay. Okay.
Yes, sir.
So from which part you start? You want to start?
So basically the electrochemistry part.
Okay, electrochemistry. Okay, we'll start it. Okay. Okay, so from Wednesday we start from electrochemistry. Okay.
Yes. Yes, sir.
And you are doing your questions or not?
Yes, sir. I'm practicing. Yeah.
Yeah. Okay. Okay. Then. Okay. Bye.
Thank you, sir. Bye, sir.
Bye.